Okay, so we're going to continue with kind of the basic skill of integration here, but look at slightly more complicated examples. So we're looking at products and quotients, so multiplying out brackets, turning fractions into things that are not fractions. Basically, you're going to be given something you can't integrate straight away, and you're going to have to write it in a way that can be integrated. So prior skills are, it's the same knowledge in these first couple of steps that you used for differentiation. So you need to be comfortable with your rules of indices. You need to be comfortable turning a function that's a fraction into something that's not a fraction. Okay, so I've got 3 examples for us to go through. So the first one is we're going to integrate t plus 3 squared with respect to t. So now there is a way of doing this without multiplying out the brackets, which would involve the chain rule, but you don't have the chain rule for integration at this moment in time, so we're going to multiply out the brackets. Okay, so remember t plus 3 squared would be t plus 3 times t plus 3. So if we were to multiply that out, we'd get t squared plus 2 lots of 3t plus 9. So we're going to rewrite our integral as t squared plus 6t plus 9 dt. Okay, now the brackets are there just to make it clear that I'm integrating every single term and not just the last one that the dt would be next to. Okay, you don't lose any marks for not having them, it's just nice. Okay, so we're going to integrate these 3 things separately. So if I were to integrate t squared, that will be t to the power of 3 because we add 1 to the power, and then we divide by the new power, so that'll be over 3. For 6t, that's going to give me 6t to the power of 2 because I'm increasing that power by 1, and then I'm going to divide by the new power. And now if I integrate a constant term, you need to think of 9 as being 9t to the power of 0 there. We know that anything to the power of 0 is 1. Okay, so we're basically saying it's 9 times 1, which is still 9. So if I were to increase that power by 1, it would become t to the power of 1. So I'm going to end up with 9t. Okay, again, I need my constant of integration because there could have been a number there before it was differentiated, because if we think about integration and differentiation being opposite processes. Okay, and that's an answer to the first one. I'm going to step it up a wee bit now and have a look at the kind of the quotients, because they're the more challenging ones. Okay, so I've got s plus s to the half plus s to the 3 over 2 all over s. So the best way to think about this was to turn your one fraction into 3 separate fractions. So we would have s over s plus s to the half over s plus s to the 3 over 2 over s ds, or with respect to s. Okay, so I'm going to simplify each of those so that I don't have fractions anymore. So s over s would be 1. So I've got s to the half over s, so that's going to be a half take away 1 if we think about our rules of indices. The powers are subtracted when we're dividing, so we're going to take away 2 over 2. So a half take away 2 over 2 is negative a half. And then for the next one, I'm going to have 3 over 2 take away 1. So that'll give me positive a half. So I still haven't integrated yet. This is me just getting it into a form that can be integrated, which is why I still have the integral symbol and I still have the ds there. We can now get rid of them in the next line because we're going to integrate. So if I integrate a constant, I'm going to end up with the variable. So it's going to be 1 times s, so 1s, plus, then I'm going to have negative a half plus 1, which is positive a half, and then we're dividing by a half, plus a half plus 1 is 3 over 2 divided by 3 over 2 plus c. So I'm going to get rid of my wee working out there, and we're just going to give myself a wee bit more room here. So s is going to stay as s, that's absolutely fine. If I'm dividing by a half, that's the same as multiplying by 2, so that'll be 2s to the half. And then dividing by 3 over 2 is the same as multiplying by 2/3, so that'll be 2s to the power of 3 over 2 all over 3 plus c. Okay. If that example is not making sense, and if it looks like my fractions, I'm kind of making stuff up, go back to the differentiation basics video 1, and that'll show you why I've done what I've done here. Okay, so one last example. Again, it's a quotient, because those ones I think are the hardest ones. So we're going to turn this into 2 separate fractions. I'm going to do 2 things at once here. So I know I'm turning them into 2 separate fractions. I'm going to do that. But the square root of u, I'm going to write as u to the power of a half. And hopefully you're comfortable enough with that now, with the amount of times you did it when we did differentiation. Okay, so still can't integrate at this point here, so let's get rid of the fractions. So this first one is going to be 3u to the negative a half, because we're just bringing that up using our rule of indices. The next one I need to think about 2 take away a half. So 2 I can rewrite as 4 over 2. So that will give me 3 over 2. So that'll be u to the power of 3 over 2 there. So now we're integrating. So I'll get 3u, now negative a half plus 1 is going to be positive a half, and we're dividing by that. And then 3 over 2 plus 1 is going to give me 5 over 2. And we're dividing by that. And again, get that constant of integration in there to make sure you get the marks. So give myself a wee bit of space. So if I'm dividing by a half, that's the same as multiplying by 2. So 2 times 3 will give me 6. So this is 6u to the half. And then dividing by 5 over 2 is the same as multiplying by 2 over 5. So I'm going to get 2u to the 5 over 2 all over 5. All right.